last few sessions we were successful in analyzing the circuits which consisted the elements. Resistor is very normal to consider, but capacitor and inductor which have a differential relationship, but we consider the operation for the circuits in which we have a sinusoidal voltage source. So I think you are well comfortable with solving the all problems where we are having the passive components of RLC and the voltage sources, current sources, may be direct source, that is constant, or may be alternating source. In that, one point which was left, that is, again it is very simple, a dependent source. We have one concept there, that is a dependent source. It actually consists of some active elements. It is prepared by some combination. In that preparation we are not interested, but we are interested in the theme of dependent source. I will very briefly explain, and it's a very simple thing which you will understand immediately and you will be able to solve the problems. So for example, what we have, let us consider simple DC circuit. It is just a new theme which once understood, there is nothing new. It is a high school level algebra. So up till now we have acquainted ourselves with a voltage source. What is a voltage source? A voltage source is that entity which maintains a constant voltage across it. It is always, that's all. A current source. A current source is that entity which maintains a constant current flow across it. Then a AC voltage source is that entity which maintains the voltage across it varying in a particular sinusoidal manner. We have not considered AC current source, but it can also be considered. AC current source, AC voltage source is shown like this, and AC current source is shown like this. AC current source is that entity which maintains current through it which varies in a particular sinusoidal manner. So up till now we have considered DC voltage source, DC current source, AC voltage source, AC current source. All of them were completely defined. For DC, a single value was defining them. For AC, we were having two values. One is amplitude, other is frequency. A sin omega t, A cos omega t, or phase we can use. That is not that way material. Now, I would like to introduce to you one more entity that is called a dependent voltage source. A dependent source. The symbol is this, plus and minus is shown so as to indicate its direction. A dependent voltage source and a dependent current source. A dependent voltage source is again a DC voltage source shown here, but whose voltage, up till now we had come across this, so we were having this symbol and we were putting a value which was constant one, right? Now the value of this is variable and it depends on some other parameter in the circuit. Are you getting me? A dependent voltage source is a DC voltage source whose voltage depends on some other parameter, maybe voltage across some other two different points, or maybe current through a particular path. Are you getting me? A dependent voltage source is very similar to independent voltage source. The only difference is that an independent voltage source has got some fixed voltage across it, whereas this has got a dependent voltage which depends on some other parameter or some other voltage in the circuit at between some points, or current in some arm, current in some path, current in some branch. So here it is a dependent voltage source. Now what we are interested in, find out current flowing through this resistor. If we found it, let us say let it be I2. Find I2. Find I2. Or even find I1 can also be a question, but find I2 is the answer. So you may try on your own. I will not give any hint. But don't go for Thevenin's theorem like that. Go for Kirchhoff's laws, and by Kirchhoff's laws you would be able to get the answer very immediately. Got the answer? What is the answer? I2. You could not find. Why? What is the reason? Simply apply Kirchhoff's laws. One node law at the middle node, and then two mesh laws. What is the problem? I am unable to understand. Why you are not able to find? Merely because it's wood. Had it been something, say 10, you could have done it. Instead of this 2I1, if it was 10, you could have done. So presume in that same way you can do. What is this current then? What is this current? I2 minus I1. apply Kirchhoff's law at two loops. So first loop, 5 equal to 10I2 plus 10I1. Is it clear? That is, you have a 5, 2I1 plus 2I2 is equal to 1. Right? Then for second, 2I1 is equal to, it is reverse. So 5 into minus I2 minus I1, or 5 into I1 minus I2, correct? Minus 5 into I2 minus I1 plus 10I1. So what is that? 15I1 minus 5I2 is equal to 2I1. So put this 2I1 here, put this 2I1 by substitution here. So this equation becomes 15I1. Sorry, it can't be that way substituted. Yes. Because it will need to on the side of it. So how did you simplify for this? What is the final answer then? Take it on the other side. So 13I1 is equal to 5I2, correct? Is it alright? 13I1 is equal to 5I2. That is I2 is equal to 5I1 upon 13. So put this here now. So what it becomes?
13 upon 13.
So putting this here, it becomes 2I1 plus 26I1 upon 5 is equal to 1. Right? That is 10I1 plus 36I1 is equal to 5. So I1 is equal to 5 upon 36. What is I2? I2
13 by 36.
30.
13 by 36. 13 by 36.
I1 plus I2 equal to half. I1 plus I2 equal to half. So it is half minus 5 by 36. That is 18 by 36 minus 5 by 36. So 13 by 36, right? 13 upon 36. I2 is equal to 13 upon 36. What is this voltage? 10 upon 36. And you can cross verify also. You cross verify it immediately. You got what you mean cross verification? Now put this I1 as 5 by 36. I1 5 by 36. I2 as 13 by 36. This voltage would be 10 upon 36, and just check whether we have made any mistake in computing the answers. it work properly? So this dependent source is just a new concept. We will not go into those details how this is to be constructed. That's not our worry right now. So we are now able to solve the problems which consist of voltage sources, both independent and dependent, resistances, resistors, inductors and capacitors. So this simple circuit analysis is over, both for AC and both for DC as well as for AC. Same you can have AC circuit analysis also. Same you can have AC dependent source also. You can also have AC dependent source. Everything is similar. I think that on this you should work. You should try to solve the problems on your own. Maybe in the tutorial, with some tutorials we may take the problem. In the lecture slots we try to move ahead as far as possible. And sometime, depending upon the suitability, we will meet on some occasion. Maybe we will meet optionally on Saturday. Optional in the sense that those who cannot meet on Saturday, for them we can meet on some other weekday. So with this, the first part, that is the circuit analysis, that is DC as well as for AC, it is actually called as steady state AC, which I had not introduced. I had not told you it is steady state. It's classic, it is steady state AC analysis. DC analysis and steady state AC analysis is now over. So after this, I will try to expose you for further discussions. That is the transient analysis. That is most important. It will have different, whether Laplace transform started, right? 5 3, right? So it's a very opportune time. So we will try to solve something using differential equations and how we can solve the same thing by Laplace transformation. So both things we can very easily match with each other. That is called as transient analysis, wherein we make sudden changes. As regards to the resistor circuit, there is no need of such analysis because nothing is going to much change. But for those things which involve inductor and capacitor, the things are quite interesting. In first week, we had just introduced ourselves on this aspect. Then we now try to introduce what we mean by transient analysis. In these things, we usually go with some resistor, capacitor. Inductor we will also consider, but it will be simple circuit which consists of resistor, a capacitor, a voltage source. It will consist of a resistor, a capacitor, a voltage source, and a switch. A switch is going to make a transition, and whatever happens after the transition is called as transient analysis. A switch is in one position, either close or open, and it changes the position, open to close or close to open. Then what is another important thing is that resistor possesses a value, its resistance, whereas capacitor possesses its value, that is capacitance, and what? No. Capacitor possesses two things. One is its value and second is its state. Capacitor has got a state, it is a device with memory. Resistance doesn't have a state. A capacitor can have multiple states, charged with Then one may say the same thing is also there. Resistance can also have voltage, but for resistance to have voltage, you need a voltage source always to be there. Means if a resistance is having a voltage of 10 volt across it, for that purpose, at that point of time, it must be in an electrical circuit wherein there is voltage source applied or a current source applied and is constantly functioning. A resistor cannot hold a voltage of 10 volts. Or a resistor holding voltage of 10 volts means always a current of 10 upon R is flowing through it. For resistor to have voltage, there must be either a voltage source or for resistor to possess voltage, it must be in the electrical circuit in which at that point of time either some voltage source or current source is active. Otherwise it cannot have it. But that is not the case with the capacitor. Capacitor can continue to hold the voltage even if there is nothing in the circuit. It is its ability to remember, its ability to hold charge across it which translates into voltage. Right? Is it alright? So, when we go for transient analysis, what is to be specified? There is the circuit configuration, component values and state of the devices which have memory. That is, if it's capacitor, what initial voltage is across it. If it's an inductor, what initial current it is having. So inductor is that way difficult to analyze. So inductor is having memory in the form of current flowing through it. Capacitor is having memory in the form of voltage across it. So we can have a simple circuit. 10 volts. A capacitor of 1 farad, an inductor of 1 ohm. Or 1 volt. 1 volt, 1 ohm, 1 farad. And a switch. And the switch S is closed at t equal to 0. Switch S is closed at t equal to 0. The voltage across capacitor initially is to be specified and let us presume that it is 0. Initially capacitor was having 0 voltage. Let us presume that. Means how? So voltage across capacitor is VO. Current to the circuit is I. Then we have to find IT and VOT if the switch S is closed at t equal to 0. The moment at which the switch is closed, we have to find out voltage across it. You may also require to find voltage across the resistor also. So any parameters, voltage between any 2 points or current to any branch is to be found out as a function of time immediately after we close the switch. So how the thing will proceed? You may think for a while. You just think. Especially the signatories on the last page, have they read what the signature is?
Yes, sir.
Huh? No, that's right. So it's all branch wise. So both of them electronics. The German chancellor would be very much happy that oh. Who is the Chancellor of Germany? Anybody knows? This kind of response is an indication of uneducated enthusiasm. What is the answer? Idea found out? It's not that way easy now. Now we are coming across differential equation. We are coming across differential equation. But by looking for solving differential equation, if a question is asked, can you solve any differential equation? Then that will require what we can say very classical base. But if a question asks, can you solve this differential equation? Then by trial and error method I may solve. So let us go by simple methods, simple approaches. So first try what is differential, what will be the answer? What is going to happen? This will be 1. From t equal to 0 onwards, this would be 1. Right? What is it? It would be equal to 1 minus 1 minus V naught k upon 1, correct? Is it alright? It for the present values, it is 1 minus VOT. Okay? And for capacitor now, what should be it? For capacitor, what should be it? dVOT by dt. Since capacitor is 1, so it is dVOT upon dt. So we can get rid of it term. So what we get? dVOT upon dt plus VOT is equal to 1. Right? dVOT by dt plus VOT is equal to 1. Is it clear? The voltage should change in such a fashion that its derivative and itself will add to a constant value. Its derivative and itself should add to a constant value. So, which kind of functions can satisfy this? What we want? Voltage VOT and its derivative should add to a constant. Should add to a constant. They should add to 1. So, exponential cannot be an immediate answer. We should satisfy ourselves. Is it clear now? What we get, since now there is a capacitor which has a differential relationship, whatever we obtain cannot be a plain equation but it's a differential equation. dVOT by dt plus VOT is equal to 1. dVOT by dt plus VOT is equal to 1. So, the function and its differential are adding to a constant figure. What kind of function it can be? Then, if we presume, let us say, in such cases, we may not be able to solve from scratch to the final answer. But, if it is provided to you that the answer is of the form a e raised to lambda t. If answer is of the form a e raised to lambda t. Answer is of the form, we can be more particular. In general, I will say that voltage and current in such circuits always, voltage and current in such circuits always is of this form: A plus B e raised to lambda t. Voltage and current, it is just a wide solution. Whenever such circuits are given for analysis which consists of one capacitor or one inductor, the solution is of the form, means voltage and current at voltage across any 2 points or current through any path is always of the form A plus B e raised to lambda t. Then you may ask me, what is this voltage in this circuit? It is 1. Yes, it may be, because it is having A equal to 1, B equal to 0. So it will allow constant to be there, it will allow simple exponential, constant, and all things it will allow. So if this voltage is this, if the voltage is this, how can we proceed further? Let us say this equation is to be solved with that. So how we can proceed further? How can we proceed further now? d by dt is what? Lambda b e raised to lambda, right? Lambda b e raised to lambda t plus what? Bot, that is a plus b e raised to lambda t, that is equal to 1, right? Is it clear? We are solving by brute force method. Lambda b e raised to lambda t plus a plus b e raised to lambda t is equal to 1. Is it clear? So by looking at this, I can find that b into bracket 1 plus lambda e raised to lambda t plus a is equal to 1. Plus a is equal to 1. Is it clear? Now, if we are able to find b, lambda and a, our problem is over. If we are able to find b, lambda and a, our problem will be over. That we can find very easily. Just we should now, in this you should match exponential terms with it's a very brute force solution. You should match exponential terms with exponential terms, non-exponential terms with non-exponential terms. So immediately what we get? A equal to 1, right? A equal to A equal to 1. That is an instant observation. A equal to 1. So A is equal to 1, right? By how you found it? By matching coefficients of non-exponential terms. A equal to 1. Put that in the equation. When you put that in the equation, what we get? They cancel. So this must be equal to 0. So when this is equal to 0, what do we get? What do we get? We get b into 1 plus lambda is equal to 0. B into 1, right? B into 1 plus lambda is equal to 0. Means either b must be equal to 0 or lambda must be equal to minus 1. Either b is equal to 0 or lambda is equal to minus 1. But now how to go for next? What is VOT? We have to assume A plus B e raised to lambda. But we have found out A. What is that? A equal to V naught T is this, right? Now, what problem we have got? We have got one answer. We have got three variables. We have got one answer completely. Now, we have got another answer but not direct answer. Either of them must be there. So, which of them is you found out? And that can be found out by using initial condition. At t equal, what I had said, at t equal to 0. At t equals what is VOT? Capacitor not chiming any charge. So at t equal to 0, it was 0. So V0, what is V00 then? 1 plus
B.
1 plus
B.
B is, right? That must be equal to what? That must be equal to what? That must be equal to 0. So what must be B?
Minus.
So B is minus 1. And since now B is minus 1, lambda has to be minus 1. Because B is not 0 now. So lambda has to be minus 1. So my answer is VOT is equal to 1 minus e raised to minus t. Correct? That's the answer. So wherever you get a transient circuit like this, assume the solution of the form A plus B e raised to lambda t and put that, you will get a differential equation converted into automatic linear equation. You solve the, you find the constants, use initial conditions to resolve the anomaly. Right? So by this way you can solve any problem. You can put inductor, you can put capacitor. You can't put both. If you put both, we may get the answer, but as regards to lambda, it becomes complex. It becomes complex or imaginary. That also we can go through. I think that we should hold for some time. We should get a good practice of these answers, right? You collect all the records.